Hello everyone, and welcome back to the channel. In today's video, we're diving deep into the art of debugging Spring Boot applications. Debugging can be a challenging aspect of development, but with the right tools and techniques, you can streamline the process and quickly identify issues in your code. First off, let's discuss why debugging is essential. Bugs are a natural part of programming, and Spring Boot applications are no exception. As applications grow in complexity, the likelihood of encountering bugs increases. Being able to debug effectively can save you hours of frustration and enhance the quality of your code. In today's session, we'll cover several topics, including setting breakpoints, using the IDE's debugging tools, logging, and debugging common issues faced when working with Spring Boot. To follow along with the examples, make sure you have a Spring Boot application set up. If you don't have one yet, you can generate a basic project from Spring Initializer. Choose your preferred dependencies, like Spring Web and Spring Data JPA, and download the project. Let's begin by loading our Spring Boot application in your Integrated Development Environment, IDE. Today, I will use IntelliJ IDEA, but the principles are the same whether you use Eclipse or Visual Studio Code. This is the main class of our Spring Boot application. Next, let's create a simple REST controller to simulate some business logic. We'll add a method that can randomly throw an exception to help us understand how to debug when things go wrong. Now that we have a basic REST controller set up, let's run our application. You can run it using the Run button in your IDE or via the command line using mvn Spring Boot run. With our application running, you can access the endpoint at http://localhost 8080/random. Go ahead and test it out. If everything works perfectly, congratulations. However, if not, let's discuss how to debug it. The first debugging technique we'll explore is setting breakpoints. A breakpoint allows you to pause the execution of your application and inspect the state of your components. In IntelliJ IDEA, you can set a breakpoint by clicking in the gutter next to the line of code. Let's set a breakpoint in the random number method inside my controller. Click in the left gutter next to the line, if random.nextBoolean, a, and you should see a red dot indicating that the breakpoint is set. Now run the application in debug mode. You can do this by right-clicking on the main class and selecting Debug. When you hit the endpoint that triggers your controller, execution will pause at the breakpoint. While in debug mode, you can inspect variables and evaluate expressions. Use the Variables panel to see the state of the application. Observe the value of the variable random and how each invocation of nextBoolean behaves. If you want to step through the code, use the Step Over and Step Into buttons on the debug toolbar. Step Over executes the current line and moves to the next line. Step Into goes into method calls to inspect what happens inside them. This level of inspection allows you to find bugs effectively. If an exception is thrown, you can view the stack trace to identify which line caused it and understand the context of the invocation. Now, let's discuss how logging can help during debugging. In Spring Boot, you have a powerful logging framework at your disposal. By default, Spring Boot uses Logback for its logging framework. To log in your application, you simply need to use the logger class from SLF4J. Let's modify our controller to add logging at various points. Here, we've added info logs before we process the request and an error log if an exception is thrown. Finally, we log the successful response. This provides better insight into the flow of the application when debugging. When you run your application and access the endpoint, you'll see log messages in the console. The level of detail allows you to trace back through your application's logic and identify where things may have gone wrong. Another common debugging scenario is dealing with beans and dependency injection errors in Spring Boot. Let's create a service class and inject it into our controller. This will allow us to observe errors related to Spring's context. Now we will inject this service into our controller and use it to perform some processing. Let's modify our controller to make use of this service class. If we forget to annotate our service class with its service, we will encounter a bean creation exception when we start our application. This is a great opportunity to observe how Spring Boot gives detailed error messages in its startup logs. Now, let's run our application again and see what happens. If we didn't annotate that class properly, check the console output. User-friendly error messages can provide clues about what went wrong. Be attentive to these logs as they often point you directly to the offending class or method. In addition to the built-in logging, you can also enable Spring Boot's debug logging mode for more verbose output. This is particularly useful during development. You can do this by setting debug equals true in your application.properties file. When you run the application with debug mode enabled, you will see a lot more output in the console. This can help you track down configuration issues or see what beans are being initialized. Now that we've covered a lot of ground, let's summarize what we've just learned. We set breakpoints to inspect and control execution flow in our application. We leveraged logging to provide insights and track application behavior. Finally, we learned effective strategies for handling Spring's dependency injection problems. Remember that debugging is not just about finding errors. It's also about understanding your application better and improving your development process. With practice and experience, you will become more adept at identifying issues before they become critical bottlenecks. Before wrapping up, I encourage you to explore different debugging techniques available in your IDE, including the various view panels and options that can significantly enhance your debugging experience. If you found this video helpful, please give it a thumbs up, subscribe to the channel, and enable notifications for future updates. Remember to leave any questions or topics you would like us to explore in the comments section below. Thank you for watching, and happy debugging! Until next time, keep coding.